This lecture will focus on when and how to do a two-way ANOVA. So if you remember back when we were talking about one-way ANOVAs, a one-way ANOVA is we use when we have an experiment that has one independent variable with more than two conditions. With a two-way ANOVA, we use this when we have two or more independent variables. So this is also known as a two-factor ANOVA, and the factor indicates an independent variable. So we're talking about factorial designs here where we have at least two independent variables, and each independent variable has two or more conditions. So remember that the simplest version of this is a 2x2 design. So if you have two independent variables with two levels each, then at the very least you have four conditions, and we have to find ways to compare across all of these conditions. But another key component of this is that you only have one dependent variable. So you've got at least four conditions with two different independent variables, but every condition is reporting on the same dependent variable. So what I want you to do is kind of pause the video and take a second to think about which tests would be appropriate in each of these situations and see if you can identify when you should use a two-way ANOVA. So the first situation is comparing the effects of a drug versus no drug on symptoms. In scenario B, you are assessing whether depression symptoms and anxiety symptoms are related. In scenario 3, you're investigating whether a drug versus not receiving the drug and the amount of exercise someone gets, 0 versus 30 minutes, influences symptoms. And then in scenario D, you're comparing whether a drug decreases depressive symptoms compared to the national average. So pause the video, take a second to think about which analysis that we've talked about would be appropriate for each one of these questions. Okay, so the correct answer of which situation you would use a two-way ANOVA in is option C. So you have two independent variables. The first is drug, and so we've got the conditions, the levels of drug versus no drug, and then amount of exercise, 0 versus 30 minutes. Each of those are independent variables, and our dependent variable would be symptoms. So just to quickly review option A, comparing the effect of drug versus no drug, we've got one independent variable here and only two groups. So we could use an independent samples t-test on that one. Option B, assessing whether depression symptoms and anxiety symptoms are related, sounds like a correlation. And option C, comparing people who take a drug's depressive symptoms to the national average, sounds like a one sample t-test because they are comparing the mean for this group to a known population average. Okay, so we've decided that we need to do an ANOVA. The next question is, what information can we get from a two-way ANOVA? So when we talk about factorial designs in the lecture, remember we talked about looking at the main effect for each independent variable. So with a two-way ANOVA, you've got two independent variables, so we will be looking for two main effects. So we will get a result for the statistic F, which tells us, is there a main effect in each one of our independent variables? And we'll need to follow that up with a post hoc test if we get a significant main effect and our independent variable has more than two groups. Two-way ANOVAs will also tell us about interaction effects. So is there an interaction effect somewhere in there? If we find an interaction effect, remember that that just tells you that something is happening, but it doesn't tell you which conditions differ from other conditions. So we'll need to look at the post hoc tests for that as well. So next, I'm going to walk you through in SPSS lesson 26 example from GNS textbook. So the example here is that an experimenter wants to investigate simultaneously the effects of two types of reinforcement schedules and three types of reinforcers on arithmetic problem-solving performance in second grade students. Okay, so we have our two independent variables. The first is the type of reinforcement schedule, 2 levels. And then the second is the type of reinforcer, of which there are 3 levels. Okay, so we've got a 2x3 design. And I am going to share my screen so that we can look at this data in SPSS. And what we can see is when we have a two-way ANOVA, we've got our dependent variable, which in this case is test. We also have our 2 independent variables, which are coded. So the reinforcer, if we look at our variable view, we can see reinforcer is our first independent variable. And this has 3 levels. Either people get token, money, or food as a reinforcer. So it's coded. And then the schedule is random or space. So that's our second independent variable. It has 2 levels. So when I look at my data view, each row, I can see that this person got reinforcer 1 and schedule 1, and their test score was 17. Down here, I can see that this person got reinforcer 2, schedule 1, and their test score was 26. So to do a two-way ANOVA, we're going to use that general linear model. So we're going to go to Analyze, General Linear Model. We are still dealing with univariate tests. So univariate indicates that we only have 1 dependent variable. We're not going to get to multivariate tests, which involve multiple dependent variables. So when we talk about univariate versus multivariate, we're talking about the number of dependent variables. Okay, so I already had this put in here, but let me move it back over so you can see what it would look like. So we just have our list of variables. Our dependent variable, the outcome is the test. Fixed factors are independent variables. Okay, so we've got reinforcer and schedule here. So a couple of things we might want to change. We could add a plot. So we talked about graphing things. So we could put the schedule on our horizontal axis and then let's do reinforcer on our horizontal axis and separate lines for schedule. Let's see what that looks like. Okay. Another important thing that we want is the estimated marginal means. This will enable us to look at the post hoc tests and the comparisons for main effects if we find a significant main effect, as well as our interaction. So we've got the main effect. It's going to give us the means for the main effect of reinforcer, the main effect of schedule, and then this asterisk here indicates the interaction, the reinforcer by schedule interaction. And we're going to tell it, yeah, we want you to compare the main effects for our main effects and then compare the simple main effects that will enable us to do the comparisons we need for an interaction effect. So we're going to continue. Let's also save descriptive statistics. So that was in options, descriptive statistics, and estimates of effect size. And we're going to say continue, and we're going to say okay. And we're going to give it a second to run. Okay, here we go. It's being pokey. Okay, so here we can see we've got our setup. We've got our reinforcers as 1 independent variable. The levels are token, money, and food. And then our reinforcement schedule, the levels are random and spaced. Since we asked it to give us the descriptive statistics, we've got the means for every condition. So this mean of 19.64 is the mean for people who got the token reinforcer and then, the token schedule and the random reinforcer. Okay. Right, the token reinforcer and the random reinforcement schedule. We've got the mean and standard deviation and the number. And so we've got that for each of this. So we could use this to create the kind of table that we've been working with in class. So that's our descriptive statistics. Next, we have the test of between subjects effects. This will give us the overall F for each one of our main effects and our interaction. So we can see we've got the overall model and the intercept, which we're not going to look at, but we've got first the reinforcer. So this is going to tell us about the main effect for reinforcer. So we have an F of 31.857. We've got our degrees of freedom here, and then we can tell that there is a significant main effect of reinforcer. We also have the main effect of schedule, which is also significant, and then the reinforce times schedule is our interaction effect, and we can see that that is also significant at less than 0.05. So we have two main effects that are significant as well as an interaction. So we need to figure out what's going on there, right? Just saying that they are overall significant is not enough. We need to actually look at the interaction or look at what's going on, which groups are different. So that is where we're going to use that estimated marginal means. And so the first estimated marginal means is for reinforcers. So this is looking at the main effect of reinforcer. So you can see this is regardless of schedule, what are the differences in the reinforcer groups? So we can see our means for each one of the levels, token versus money versus food. These pairwise comparisons are your post hoc tests, and it will tell you whether there's a significant difference there. And so what I can see by looking at this, it looks like token is significantly different than money and food. And that's really where the difference is. And if we go back up to these means, I can see that the mean for token is significantly lower than money or food. Money and food are not different, but token is significantly different from the others. Okay. Next is reinforcement schedule. So again, this is the main effect of reinforcement schedule. Is there an effect of reinforcement schedule regardless of what reinforcer is provided? So here we only have two levels, random versus spaced, and we can look at these means and see that it looks like it's different, and in fact there appears to be a significant difference. So it looks like the spaced reinforcement schedule leads to higher test scores than the random reinforcement test schedule. And then finally we get our interaction effects. It'll show you number 3 and 4 will both be your interaction effects, looking at it different ways. So you can look at whichever one makes the most sense to you. But here we have our means for each group. So these are people who got the token reinforcer and a random reinforcement schedule, had a mean of 19. Those who had token reinforcers on a spaced schedule got 26, had a mean of 26. And again, we have our pairwise comparisons. And so we can look at it here and see if we can identify a pattern. And what it looks like is basically every one of the conditions is different in the spaced reinforcement schedule. All of these are significant. Everyone is different from the others. In the random reinforcement schedule, it looks like food and money are not significantly different, and that's the only place where we see that non-significant difference. Let's look at our graphing. And so we can look, this looks a little bit different from the graphs that we made in class, only because we have, instead of a 2x2 design, this is a 2x3 design. But what you can see here is that in general, it looks like the spaced reinforcement schedule led to higher test scores for token and money reinforcers, but for food reinforcers, there wasn't a significant difference between random versus spaced. So that is how you would do the SPSS output. When you write up your results section, you want to make sure to describe the overall effect, so the overall main effect of one, main effect of the other independent variable, and the interaction effect. And then it's not enough to just report those overall effects. You need to also report those post hoc tests and describe what is significant and where those differences are.